you so much. And yeah, I think those of you who clapped before, I think you maybe agree with me that you hate writing tests. So yes, so yeah, I hope I'm going to help you by giving you this talk. So let's see. Oops. Okay. So what do you think is the most difficult part of writing tests? So I double click, so I already show you my first one, which is importing the code. Because I'm a very messy person, by the way, if you know me. My room is very untidy and stuff. So also, my code, I try to be tidy, but sometimes, I got too many files and then they're all mumbo jumbo. So sometimes importing the code is very challenging for me because the Python just can't deal with my messiness and can't get my code into the test suite. But anyway, so next thing is to organize the tests. Because again, I'm a very messy person, so organizing the code is already very challenging. So to organize the test is extra challenging because, if you have write unit tests, if you're a good developer or data scientist who tests your code and have write a lot of tests, then it soon become very, very big and you have a lot of tests, right? And because you have to test different scenario, different cases and stuff. Oh my God, like it's a huge, if you have a huge library or a huge amount of code, you would basically double the amount by having everything tested out, right? So you were pushing for the 100% coverage, right? So it's like a lot of tests. And also think of the test case, because test case, sometimes difficult is, again, we don't want to write too many like parameters to test our code with all these like different, what if the user have this input? What if we have this data? To test to cover all the grounds, right? Like sometimes we don't know what we should do, whether like what is the edge case, maybe what if we have a missing data, empty string, what happened? So I don't like testing. I don't like testing. But with hypothesis, actually, we can save some trouble by the last two. It doesn't help you to import the code. If you're a very messy person like me, then you have to learn how to be less messy. But for the other two, actually, hypothesis may help you. So what do I mean? So hopefully, I'm going to explain later. But before that, I'm going to tell you about myself. So I'm Cheuk, hello. And I work for Anaconda. So we are all working with data. So you may heard of Anaconda, that we are, a distribution of some like Python with all the like scientific packages. But we also do a lot of different things nowadays. For example, PyScript. So if you want to know more, talk to me afterwards. And I love open source project. I have been involved in multiple open source projects in the past. I contribute to some of them. Also, I organize a lot of events. So that's a few of them that I have been involved in the past. And I love seeing people. So, have you heard of this thing called property-based testing? Oh, no, some, yes, no, yes, okay. So, property-based testing, how am I going to explain to people, right, when they are new to the concept? So, I would say that what we normally do when when you learn how to code, or when you like kind of look at the textbook example that like, oh, this is unit test. So those usually are done by test by example. What do I mean by that, right? Because test by example, like the name suggests, you have to provide example. You have to provide like what needs to be tested. So for example, you have a function, you want to test that. You have to think that, some input may be coming in, then it may be a number, right? So a number that is 1, or maybe it could be 0, or it could be a negative integer, or it could be a decimal number. So you have to think of what is an example that you would like to test. And also, with that input, also what are you expecting to come out, right? So those are all the examples. Test by property is the other way, kind of, is a little bit different. Instead of thinking, okay, I need to test 1, I need to test 0, I need to test 2.5, I just say that it's a number. It's a number. It could be decimal. It's not an integer, but it's a number. So that's test by property. So instead of thinking about what the input or what the what the parameters that you put into the test of the function, what is the property of that? So. Oops, I hope it worked. Okay. So if you type your code, right? So now, with all these modern version of Python, I would say like 3.9, 3.10, 3.11, we already have the typing library built in. So actually, the community is now starting to get into this practice of typing your code. You would, for example, you have some parameters. You would say that should be an integer, that should be a string, so on and so forth. Or what is the output of this function? So we type everything, right? Even though Python is well known for duck typing, which is very beginner friendly, but as we go along, when we like really writing production code, we have to be more clean or careful about this. So we type our code. And by that, actually, it works very well with property-based testing because we just think of what's the property of that variable, of that parameter. But if you test by example, again, of course, we know when we see that, okay, this is supposed to be an integer, then I can come up with some integer, it's fine. I'm smarter than hypothesis, kind of. But, you still have to do extra step for all your tests. And also, edge case. So again, like if let's say you test the integer, right? What are you testing, right? Do you test a very small integer, test a very large integer? Do you test 0? Do you test negative? Is negative integer okay? And stuff. So you have to think of all these cases that, for example, if you test positive integer, you test 1, you test something very large, maybe you won't test 3, 4, 5, 6, 7, because, if 1 and 2 is fine, then maybe 3 is fine. You don't have to test every single integer. You just need to test the edge case, maybe a very large integer, right? So, but then you have to think of that yourself. Testing by property, if we choose the right strategy, if the strategy is written correctly, then these edge case logic should already be embedded, so we don't have to worry about that ourselves every single time. And so hypotheses, like I said, they provide a lot of tools that can help you to do the property-based testing properly. So first of all, when you do hypothesis, so the first thing you will do is to use some decorators. So for those of you who are familiar with PyTest, PyTest provide lots of decorators as well for you to help your test to be more clean and powerful. For example, if you have a lot of test cases, you can use parameterize in PyTest, and then you will, you just need to use a decorator. So hypothesis is similar. You use a decorator to modify your test so that it would take in an input, and then we just say what the strategy we use for that input. So now I mentioned strategy, so we need a strategy, right? So in hypothesis, there's actually already some strategy that's written for you. For example, there is the text, which is for the strings or the numbers. There's a lot of things that is already in there, so you don't have to write your own strategy. You don't have to be like, okay, if it's an integer, make sure you test 0 and all stuff. You don't have to because it's already there, which is good. And because everybody used the same strategy, so if something's wrong, someone may already make a PR or something, right? So it's good. We like reusing things, right? We don't like inventing the wheel every single time. So this is an example. So this is actually, if you look at the hypothesis documentation, you will see this is basically like a one-on-one example. It's very good because I wish I could show you, but because technical problem, I can't show you, but I would tell you what happened if you try this out yourself. But anyway, this is the example. And it's a very simple code. It got only 2 functions. One is encoding something. So the other is decoding something, right? So it's very simple. You don't have to look into the code and see like, okay, what's going on there? How do you encode it? And don't worry about that. We just use it as an example. So we have a very simple kind of code that we want to test. So we create a test. So this is using hypothesis, so this is the most simple case possible. You only need 2 things, the decorator that we're using and the strategy. So the decorator that we're using in this case is called given. So it's just that we say, we give the property to this variable. And then we have to pick the strategy. So in this case, because we're encoding some strings, so we use the text strategy. So this is how it goes. You just put it there, given a text. So so we only have one variable here, so there's no which one go first, but we have the variable s here, which will be a text. Okay, so this is how we test it. We do this. This is called round trip, which means that we encode a text and then decode it. If this pair works together, they should give us back the original thing, right? It's very straightforward. So again, you can look at the documentation if you want to look into the detail. If you want to try it yourself, you can try it yourself. So So, okay, this is the time when I'm showing the demo. I will show you how does it work and stuff. So what happened is that you may not find out just by dry running the code, but what happened is that if you run this test, you will have one error. So the error says that if S is an empty string, then it will fail. So, what happened here? Hypothesis found a edge case for you, which is like when you write the logic of the functions, you may be overlooking that, what if something is empty? Then it will give an error. But if you use hypothesis to test, because sometimes, we have blind spot, right? When we write the test ourselves, we may think of the case that we were thinking when we were writing the code, right? Since we are not already thinking about the empty string, when we test it, we may forget to test the empty string. But hypothesis will find that for you. So instead of thinking, okay, I may test 1, 2, 3, 4 as a string, or I can test apple or hello world as a string, then hypothesis will find the case that is usually we call it edge case, the case that we usually overlook for us to test. So voila, that's how it works. And thank you. And but I haven't finished yet. So for hypothesis, why am I like talking about it like in PyData, right? I'm telling you this because it's not just useful for developer or coder. It's very useful. It has the scientific thing in mind that we have a lot of things that support the library that we love and use a lot. For example, NumPy, we actually have things in hypothesis that are designed to use with NumPy, for example. But before that, before you use it, right, don't forget to install the extras, because hypothesis is a very big library, and for people who may not be doing scientific programming, they don't need it, right? They never use NumPy, so they don't need. So they would just install the core hypothesis. So they just pip install hypothesis, but that's without the NumPy thing in there. So if you want to use this thing that I'm going to tell you in these 2 slides, make sure you install it with the square bracket NumPy there. I think if you are using a ZSH shelf in Mac, like if you're a Mac user like me, then you may have to put a code there, because the square bracket, they don't like it. The shelf doesn't like it. So you have to work around. But it's fine. You'll find a workaround. So after you have installed it, then you have this. So this will be in your hypothesis. It's sitting in extra. So it's just in NumPy, so you can import stuff from there. You can import strategy that is designed for NumPy. For example, the scalar, NumPy scalars, you use it a lot, and arrays. What NumPy is like powerful for is because they have all these like vectors and arrays that you can do this calculation very quickly. So you may want to import that type. For example, if you're expecting a NumPy array in your function, you can use hypothesis to test your NumPy array, which is great. So yeah, if you want to, again, look into the documentation, if you want to know the detail. Also, it supports Panda stuff. So wow, how do I do that? Again, install the NumPy. It's kind of together, so it's install NumPy, it's not install Pandas, but it's fine, because Pandas use NumPy under the hood anyway. So it sits inside the extra.pandas, so it's there. And then from there, you can import the strategy for the NumPy index, the NumPy series, and the NumPy, the pandas index, pandas series, and pandas data frame. So we use a lot of data frames, and what if we can have a strategy to test the data frame? We don't have to, for example, you're testing some kind of data pipeline, cleaning data or something. So instead of have to make up with some kind of testing example of your data frame, you can use hypothesis, which is good. I'm lazy. I don't have to write tests. Yay. So talk about lazy. I'm so lazy that I don't even want to write tests, right? So remember the first example we have is actually quite easy to use hypothesis instead of writing many, many tests with many, many cases and think of the cases as well. You can just hypothesis, think of the test case for me. But I'm so lazy that I don't even want to write any code for the test. So I hate myself. But hypothesis still love me. Hypothesis still want to help me. So we have Ghostwriter. I don't have to write it myself. Yay! But if if you are very good, like, and remember, there's a kind of a small things here at this slide. It's like, I hope you're still using typing, because if you're not using typing, the ghostwriter doesn't know what you're trying to do. So it doesn't help a lot. So the ghostwriter is very smart. The ghostwriter will write tests for you. And so what it does is we use typing as a hint. So remember, nowadays, maybe it's a good practice, or your team require you to type every single thing. So now it's great, because now you don't have to write the test. You just spend time in writing the typing. You don't have to write the test. So the ghostwriter is very smart. If you see the typing, it would find the right strategy for your parameter. For example, again, integer, it will find the number, string, it will find the text. So for all those like standard strategy, even for example, if you type it as a pandas data frame, then if you have installed extra, GhostWriter will know that, okay, I'm now finding the strategy for the pandas data frame. Yay! That's really good. So it's a CLI tool. So you just type it in your command line interface, and then it will just generate all the text. You can pipe it into another file, and that's your test. You don't have to even write a single thing. You write a single command. That's it. So also, if you, for example, like me, right? I'm lazy, but I'm messy. So I love Black, which is a formatting tool, which will make my code very tidy for me. And GhostWriter know that as well. So when you use hypothesis and generate the test, nobody knows that it's not written by you, because you're also using the Black to format it, so it stays the same style, which is good. And yeah, that's really, really good. So this is how you generate the test. For example, you have written, well, I think that you are not it's not written by you, because gzip is the standard library, right? But imagine we write this gzip library. So it's a standard library that got lots of function in it. So if you ask me now to write a test for gzip, I'll be scratching my head and it's like, no, I don't want to do it. But if you use hypothesis will happily do that for you. Again, I can't show you now because my computer doesn't like the projector. But you can try it. If you have a laptop here now, if you have hypothesis, you can try it, and it will generate a lot of tests for you. And it's good. So, okay, so why the ghostwriter is so smart? What do GhostWriter do? Because, I can't trust a stranger to write tests. I can't trust GhostWriter to write tests. So I want to know what they are doing. So here's what they're doing. So first of all, one of the GhostWriter that do is to write a fuss, which is just test your function to see if it works, right? This is the most simple thing. We want to just run the function, run it through, so there's no bug in it, and it kind of works properly. Sometimes, you have your function may raise an error, so you can also write the exception there as well. So if, it will be working fine until you have this exception that you have written that, if someone be naughty and put something in there, then you have this error that you're expecting, then you can put it there. So idempotent, I always don't know how to pronounce this word. It's so difficult to pronounce it, but the concept is very simple. For example, sometimes you have a function, and then running it once should already get the task done, and running it 2 times, 3 times, 4 times, it doesn't help. So, for example, sorting is one thing that's like that. So after you have sorted, if you have done it properly, the order should not change, right? So you can run this, and then so GhostWriter will generate tests for this. So again, so this one, I think you have to tell GhostWriter that, oh, this is a function that you do this. But sometimes GhostWriter is very smart. You don't have to tell GhostWriter that I'm using this, because this is a function that should be, haven't changed. Round trip is my favorite one, because GhostWriter will know that you have a pair function. It's amazing. To try this, you can try it yourself. Again, you type hypothesis write JSON. So JSON is the standard library that have a lot of things that you can work with JSON. For example, JSON dumps and JSON loads. So they are a pair. Again, it's like encoding and decoding. One of them is changing your dictionary into a JSON string. The other is doing it the other way around. So they are a pair, and they should be, round trip should go back to where it was, right? So you encode it and you decode it, come back to where it was. So hypothesis will no. So you can, of course, first of all, you can, of course, tell hypothesis that this is a pair. Use round trip to generate some tests for me. But if you, for example, test the JSON suit, the whole suit, then, when GhostWriter go through all the function, they would use the fuzz to test the function. But when they see, wait a second, JSON dumps and JSON loads, I think they are a pair. I would use round trip to test them. So this is how smart GhostWriter is. And yeah, I really love it. So, yep. So I think this is the last thing that I want to bring into your attention is the equivalent. So equivalent is useful when you are reinventing another function. So what it does is that it will take a function as the truth, right, as the correct answer, and then test it against the one that you are testing. So for example, this is just an example. I think it won't work because, well, it will work in some way that like my function is not perfect. That's what I mean. So because if you think, what if y is negative? Yeah, then it won't work. So what it does is that I take the math.power, so that's the power method, right? So if you have been paying attention in the keynote today, you know that, in math, there's a lot of amazing things. They have been, optimized, they've been tested, and I would take them as the truth, right? So, okay, and then now I write a, x to the power of y function, and I want to test it against it. So this is how I do it. So, and then I'm sure hypothesis will tell me that, your thing is kind of sucks because what if y is negative, then it won't work, ha ha ha. So, yeah. So there's actually two more, but those are less, appear less, it will be less used. That's why I put it here in one slide. So for example, binary operation. So sometimes, we write some custom binary operations. So it's like the plus, minus, equal, all this stuff. They are binary operators because you have two things, two things that's binary, and then there's operator. So if you have custom-made one and if you test them, then that would be helpful for you. The other thing is UFung, NumPy have a lot of UFung, and then, it would detect this, okay, NumPy and UFung, I would test something for you. So GhostWriter would do that as well if you tell GhostWriter to do it. So I can't try it now, so because the demo doesn't work. So I think, this is close to the end of my talk, and I want to, because I always kind of balance my opinion out. I don't want to be like kind of brainwashing and say like you must use GhostWriter and hypothesis and they are great. I want you to also consider these things before you really deploy hypothesis to all your code, right? Be careful. don't trust me 100%. So. One thing that, for example, I've talked with the maintainer of scikit-learn, and then we're talking about, hypothesis actually is quite useful. Have you, used hypothesis to run the test for scikit-learn? They said that, we have tried, but actually it can be very slow because, scikit-learn is a massive library. It got a lot of things in it. If each one of those parameters, you have to generate a lot of test case and test everything, it will become very, very slow, and it's, so maybe. So I think what they do is now is like they only pick a few things that is like really useful to use hypothesis. They only use hypothesis on those, but not the whole thing. So so it's something you may have to also consider if you have a lot of code, a very complicated pipeline. Maybe only pick a few section of your code that actually hypothesis will help you the most, and then only use it there. The next thing is that tests can be a little bit hard to understand because until you run the code, you don't know what the test case are that hypothesis use. You can, of course, check the source code and found like what strategy are you using and what the strategy generate and stuff. But it takes extra steps. So if you really care about what example you put in your test, then you can work around by not using given but use example. But that's more or less the same as test by example. So there's a benefit, but also some drawbacks. The last thing, again, I think hypothesis, especially the GhostWriter, work the best if you have very good typing in your code. So if you don't have typing in your code, I won't recommend you to use the GhostWriter, because it will still help. It will still generate the skeleton of the test for you, but you have to go inside and change all these strategy. You have to pick it yourself, that what strategy you use. So you can still try, but again, you are not getting the most benefit if you are not using typing. So beware of that. You can't just be okay, I'll use GhostWriter generate and then just run the test. If you haven't typed your code, then you have to go to check everything before you run the test. So I think that's it for my presentation, and thank you so much. And Q&A time. Oh, by the way, I will go back to the front because there's a link to the slides, so you don't have to ask me for the slides. But any questions? Do I have time for questions or not? But this is the slides. Yeah. Yes, there's a very confident. Sorry, will people pass the mic, or do I have to repeat? Machine learning model, does it work on machine learning model? Is that your question? So for machine learning model, I think if you have a pipeline, right, you can kind of test your pipeline to see if, for example, this section, if you're cleaning the data and all that stuff. But if you're testing whether the model is doing its job, then I think it's out of the scope of hypothesis. Because you have to see all the your test set. You have to have a test set and test it and compare the score and use different metrics and stuff. The hypothesis is not that smart. How much can you control the input for the test? So all those are generated by the strategy. So there are strategy that is already built in for the library. Then if you want to know, you can of course check the source code, or you can write your own strategy if you want absolute control, or if you just kind of again, if it's a thing that you really care about what cases that is used, then you should maybe go back to test by example. So yeah. Yes, there's one hand at the back. Oh, we found the mic. Yes.
Hi. Do you have any plans or integrations with tools like Great Expectations that allow you to write assertions about data distributions and types? Do you know Great Expectations or Y-logs or other kind of data testing tools?
So is it so? Why can you shorten a little bit? Why do you use the certain cases or?
So Great Expectations, for example, is a tool where you can declare properties that your data sets should have, and then you can run it either in line with your pipeline or in a testing mode. That doesn't look it looks more like at the output rather than, it doesn't generate input that triggers the expectation.
So it's another tool that you talk about, right?
Yes.
So what's the name of it?
Great Expectations.
Great Expectation. Okay, I have to check it out. So I don't know. So yeah, I will check that out. Yes.
When you use typing for stuff, objects like standard data frame and series, you still don't know what actually is the data type that is expected in the data frame.
Yeah.
Find edge cases for if you don't know if it's going to be text or
Yeah, you can. I think so. I haven't touched the pandas one for a while, so I really don't know. But I think you can declare that what kind of type that is inside the data frame. I think for NumPy, I think I've worked with that one before. I have a PR for that. That you can you can kind of declare what the type inside is. So yeah. Yes.
How would you combine PyTest and hypothesis together?
Yes, that's a very good question. That's what I normally do, is to use hypothesis with PyTest. So actually the example here, that if I can show you again, the example, okay, it's quicker, it's like this. Okay, the example actually is using PyTest, this one. If you look at it, this is actually using PyTest. For hypothesis, there's also, I think there's a parameter that you can also change it to have us use it with unit tests as well. So it will use both, but I think most of the time, in my experience, I use it with PyTest. So yeah, so it works. Thank you.